Hi everyone, this is Mel. Today we're gonna go through Polynomials, Chapter 6 Summary. This is Master Method, Unit 1 and 2 of VCE subject. Okay, so for polynomials, commonly we have cube functions and quadratic functions and to the power of 4 functions. Okay, let's go through bit by bit. The sum, difference, and product. Sum, difference, product of two polynomials is a polynomial. However, the division may not result in a polynomial. So the powers, if they're the same, they might cancel it out. So that's not a polynomial anymore. Okay, let's go through remainder theorem. This is very important in polynomials. When px, so function px, is divided by x minus alpha, the remainder is equal to p alpha. So if you have a long polynomial, let's say, here's the example, let's say x cubed something 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 divided by x minus 2, the remainder should be p2. So you substitute x is equal to 2 into the function, this one, and you should get 25. This is the remainder. Okay, that's for remainder theorem. And the remainder theorem is somehow related with factor theorem. So what is factor theorem about? For a polynomial px, if p alpha is 0, then x minus alpha is a factor. Or in other case, we can say if the polynomial divided by this term do not have a remainder, so the remainder is 0, that's p alpha is equal to 0. And that means this thing you divided by is a factor. So if you factorize the px, you should get x minus alpha times another polynomial. Let's say small px. Let's look at an example. If we have x cubed minus 4x squared plus x plus 6. So if we have p negative 1, if we put in negative 1, then we get a 0. That means x minus negative 1 is a factor, which means x plus 1 is a factor. Be very careful, it's not x minus 1 is a factor. Or at least, from this one, we cannot get x minus 1 is a factor. So this thing you put in, you should minus that, and that is your factor. So x minus the minus 1 is your factor. The whole thing is a factor. So, commonly, we just try the factor of the last constant term, so 6. We try plus or minus 1, plus or minus 2, plus or minus 3, and even plus or minus 6. These are the factors of the 6, of the last term, last common term, constant term. And we try these values and put it in the function p to see if it can satisfy the 0. Okay, so commonly after that, after we get 1, we get negative 1 to be a factor that makes it 0. Then we usually divide px using long division with a factor and then get another polynomial, and then so on and so forth. So from this step over here, we can conclude x plus 1 is a factor of px. Okay, the sum and differences of cubes. So if we have x cubed minus a cubed, then we can factorize it as x minus a times x squared plus ax plus a squared. And if we have a plus here, then it's also plus here. and then here is minus. Okay, for example, commonly x cubed minus 3 cubed, or this should be 2x cubed plus 4 cubed. Or we can take the 8 out to be x cubed plus 2 cubed, and it's the same procedure. Okay, now the rational root theorem. So now we do not have, so for previous examples, note that we have the leading term with a constant 1 in front. But now we have another not one constant, for example an, and a constant term a0. This is a more complicated polynomial with degree of n and coefficient ai, integers. Let alpha and beta be the integers such that the highest common factor of alpha and beta is 1. So alpha and beta do not have a higher common factor than 1. Or we can say alpha and beta are relatively prime, so they're prime number. For example, 3 and 5. Or 2 and 3, or 2 and 5, and so on. If beta times x plus alpha is a factor of px, then beta can be fully divided by an, and alpha can be divided by a0. Or more commonly in the questions, it's like the p negative alpha divided by beta is 0. Then that means beta x plus alpha is a factor of the polynomial. And how do we find alpha and beta? So we said already alpha divides an. So beta divides an. So for the leading constant an, so if, for example, an is 6, then we can have beta as plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And same for a0. So alpha is a factor of a0, and beta is a factor of an. And that's how we try this negative alpha divided by beta, and to see if the p of this thing is 0. If it is, then this one is a factor of the polynomial. Okay. Steps for solving a cubic equation. So if necessary, rearrange the equation so that the right-hand side is 0. So into a form of a polynomial equal to 0, something like that. And factorize the cubic polynomial, factorize. If we can factorize, then that's perfect. So we directly get a factor and we can solve it. So into a multiplication form. So x minus something, then we can solve it directly by applying each term equal to 0. Third one, use the no factor theorem to determine solutions. And that's the factor theorem and rational root theorem we talked about earlier. Okay, for example, this one over here. It have right-hand side of 0, and let's see if we can factorize. Directly, we cannot see anything, but if we try the 30 with factors of 2, then we know the P2 is 0, then we know x minus 2 is a factor. Then using long division, with a factor of, then you can get x squared, and then something, which is this one. And then we can easily factorize a square function. And this gave us the final answer. Okay, the basic shape of x cubed is like this. So when x is 0, y is 0. And when x is positive, y is positive. When x is negative, y is negative. And this point, 0, 0, is point of inflection. Okay. The implied domain of all polynomial is R. So the x value can be, we can take any x value for the polynomial functions. The function f(x) is equal to x cubed, and the function f inverse x is equal to x with power 1 on 3. So these are two inverse function. If we draw this one with the same graph over here, it should be like this. This is x cubed. So their inverse function, which is metric with the diagonal line y equal to x. Okay, the graph of y equal to a times x minus h squared plus k has the same shape as this one, but translated h unit in the positive direction x-axis and k unit positive direction y-axis. So k unit up if k is positive, and h unit to the right if h is positive. Okay, the basic shape of the curve of the x to the power of 4 is like this. So instead of the quadratic function, you have something like this, x squared. So the interval between -1 and 1 will be more flat, will be flatter. That's the difference. The graph of this one has the same shape as y equal to ax to the power of 4, and also with the same translation of h and k, same as this one we talked about earlier, and the turning point, h and k. So in this case, we have turning point of 0 and 0, which is actually a stationary point, local minimum. And if in a general form like this, we will have a turning point, h and k. And in the cubic function, I forgot to talk about it. The h and k, hk, is a point of inflection because the h and k in the normal x cubed graph is the 0 and 0 point, which is indeed a point of inflection. Okay. So a sign diagram. This is very interesting, sign diagram, which you don't show any shape, but only the sign, the positive or negative, positive up, negative down. So down the axis, x-axis. So it only shows sign and the intersections. For example, we have this function. The very important thing about sign diagram is that the constant in front of the leading term. If it's 1 or any positive number, then it should start from the right-hand side up, somewhere here. And the second important thing is the intersection with the x-axis. So if it's x plus 1, then I have -1 here, and 2, and -3. So my graph will look like this. So we start from the right-hand side, up, and then goes through the point, through the point, through the point. There's another case when we do not cross the points, the intersections. If we have, let's say, x plus 1 square, x minus 2 cube, x plus 3. So we also do start from the right up because the leading term constant is 1 over here, which is positive. And note that it's a 2 over here as a power. So that means we do not actually cross the x-axis at the -1 point. -3 over here. And because this is an odd number, so this depends on whether the power is odd or even. So if it's even, then we do not cross. If it's odd, then we cross. So normally we have 1, the power 1. So we do cross all the axes. Okay, so still from right and up, we cross 2, we do not cross 1, and then we cross 3 again. That's what it should be looking like. So how do we draw a sign diagram? So for this graph over here, it's positive, it's negative, it's positive, and negative again. And that corresponds to every area on the sign diagram over here. So above 2 is positive. From -1 to 2, it's negative. It's negative. And from -3 to -1 is positive. And lower than -3 is negative. Okay. And what about this graph over here? So it actually looks like this. So this point is -3. Positive, negative, positive. Although we do touch the point, -1, it's also negative below. Okay. So steps for sketching a cube function. We use the factor theorem and division to determine the x-intercept. So it's very, very important to factorize a polynomial because you'll get the x-intercept. Okay? The y-axis intercept, just to let x is equal to 0. Then you get a y value. Draw a sign diagram. Yeah, that's the steps for drawing and finding the equations for given cubic graph. So this one is typically in a intercept form or factorized form. And this one is in a general form. So with a factor n, with the thing you want to translation. So this based on y equal to x cubed. And then you do a dilation, you do a translation, and then another translation. So you kind of move the graph x cubed and do a transformation to get the final graph. However, for part I, we factorize it first and then use the intercept. And if this case a is greater than 0, because it's right and up. Okay. And we use the intercept and the the leading term constant to determine it's right up or right down. If a is negative, then we start from here and do some other curve like that. Okay. So a function f is even if f negative x is equal to fx. And if it's odd, then negative x is equal to negative fx. So what about our function x cube? Then obviously it's an odd function because the negative x, for example, negative 1, is equal to the negative of f1. Then for the x squared and x to the power of 4, these are the even function. This one is an odd function. A power function is a function with a power. R is a non-zero real number. If it's 0, then it's just a constant. Okay, that's all for today. That's for chapter 6.